In this video, we are going to take a quick look at Retrofit. Now, Retrofit, as you can see at the top of the page, is a type-safe REST client for Android and Java. And for people who don't know what REST is a sort of architectural guideline for building web APIs. So you can kind of infer from that what we're looking at is a library that makes working with online services easier. And Retrofit is really, really built for Android and Java, and it works incredibly well with Android and Java, and I highly recommend it for virtually all the sort of web API things that you may need to do. Now, the application that we're building is very, very dependent on the API, and we will be using Retrofit for virtually all of our HTTP traffic. So if we need a web request done, we're going to use Retrofit to do it. Now, Retrofit is very, very simple and straightforward to use, though very powerful, and reduces the amount of code you have to write significantly. So in this video, I just want to introduce you to the core concepts of Retrofit. Now, the documentation page that you're looking at right now does a pretty good job of explaining it, and it's a very, very good reference. So I'm not going to go over how to use every single little thing of it. I just want to give you guys a feel of how to use it and let you guys go and explore it yourselves. Now, in the app that we're building, of course, we're going to be using Retrofit, and we're also going to be using more powerful features of it. We're going to be using a custom system for handling authentication tokens and errors, and also we're going to put together a tiny little thin abstraction over Retrofit to make it work better with our API. So all the advanced stuff we're going to be taking a look at in the next couple of videos that won't even necessarily be covered by this documentation. But again, I want to give everyone a quick taste of how you can use this pretty effectively, pretty quickly, and showing you guys an end-to-end sort of solution for it, and basically talk about some of the best practices. So yeah, I guess let's go ahead and get started. Just like they do on the documentation page, I'm going to be looking at the GitHub API, and I just like looking at the GitHub API because it's very clean, very easy to use, very easy to discover. In fact, if you wanted to know more about the GitHub API, simply go to https://api.github.com. As you see, you get a JSON result with links to many of the major endpoints here. Now, the endpoints that I'm going to be working with in this video, just to show you guys the basic use of this, are the gists endpoints and the users endpoints. So, for example, this gist URL, or not that one, but the public gist URL right here will give you a nice little list of all the recent gists that have been made on gist.github.com, you know, like Pastebin, if you're not familiar with that. We're going to be first taking a look at how we can parse this very quick and easily in a synchronous manner, and then we're going to move on to a slightly more complex example with user searches, and then finally we're going to be taking a look at how to deal with asynchronous requests using Retrofit when we look at getting details on a user. So I guess that's enough talking. Let's go ahead and get going. There's not going to be a whole lot of code to write, which is pretty much the whole point of Retrofit. Also, it's funny, you might have noticed that Retrofit is a Square project, just like Picasso is, and yeah, I'm a big fan of theirs. I really appreciate their open source work. Anyway, I'm going to go ahead and create a new project right now, and we'll target 4.2, that's fine. And I'm going to open up with a blank activity, and I'm going to hit finish. Now I'm going to let Gradle do its thing over on whatever monitor it decided to pop up this time. So give it a second, or 5. And all right, we have this guy. So what I'm going to do, there's a couple modifications I want to make here, but before I do that, let's go ahead and actually pull Retrofit into the application. So we're, of course, going to be using Gradle because Gradle has been a very, very excellent package manager from, or build tool from my experience, and we're going to use that to pull in Retrofit. So if you go back to the documentation page, you can scroll all the way to the bottom to get multiple ways to get Retrofit. Like, for example, you can download the jar directly, you can use Maven, or you can use Gradle. Now, it might get a little confusing if you're quickly scanning through the page because they have another section of Maven and Gradle down here, but this is for using OKHTTP integration, which is another product, open source product by Square that we'll be using to do some more advanced things with Retrofit. But for now, what we're going to do is we're just going to grab this guy right here, this COM Square Up Retrofit, and then the current version of whatever it is. We're going to be using 1.9.0 in this video. So I'm going to just get that on my clipboard, and I'm going to open up my module app build.gradle, not my project, but my module app. And I'm going to locate my dependencies block, and I'll go ahead and paste that in. Now I'll go ahead and give maybe give Android Studio a chance to show my sync thingy. I guess it won't. So we'll just have to do that manually. Sometimes a little thing pops up when you edit a Gradle file that asks you to sync it. Otherwise, just go up here to Tools, Android, and say Sync Project with Gradle file. You need to do that because we changed our dependencies, and Gradle has to go out onto the internet or your local cache to grab that package and import it into our class path. But that has been done, so we can close out of this. We don't need to be in this file anymore. And now we're in our activity main.xml. What I'm going to do in activity main is I'm going to remove this text view, and I'm going to replace it with a list view, which will be mash parent for the width and height. And I'm going to go ahead and give it an ID of activity main list view. So pretty straightforward. This isn't a video about building UIs in Android. We're just going to have a nice little list view on that. And what I'm going to do here is I'm just going to nuke the anything that has to do with the options menu. We are not going to be using the action bar in this video. Okay, so the first thing that I want to do is get just the do a couple of plumbing things. Get the basic sort of structure that you would need in order to start working with Retrofit. And the first thing you're going to need is, as you saw in the documentation, maybe if you started reading it, you'll notice that Retrofit is really based around this concept of an interface. And the interface, what it does is it generates a class for you that implements that interface, where those interface methods get turned into what turn into calls to the API. So we'll need an interface. And so I'm going to write a private interface. Doesn't matter if it's private or public, really, in this example. And it's going to be called a GitHub service, because that's a fine name right there. And then we're going to leave it blank because, like I said, I want to show you guys just the sort of things you need to get going with Retrofit first before you start adding your API calls. So next up, what we need to do is we need to create a REST adapter. So I'm going to create a REST adapter, and I'm just going to call this adapter, and I'm going to say equals new REST adapter.builder, and then I'm going to do .set endpoint to HTTPS API github.com, then I'm going to say .build. So the REST adapter builder, if you look at the autocomplete, shows quite a few different things you can do to modify or configure how Retrofit is going to work. Now the REST adapter is what is going to get an interface and turn that into a nice little service layer for you. So now that we have our adapter, we can get our service. So I'm going to say GitHub service equals adapter dot create GitHub service dot class. So in reality, to work with Retrofit, this is pretty much most of the stuff you need to memorize. This is pretty much just the basic putting it together, getting it going, although it doesn't do anything yet. Now, before we make Retrofit do anything, there's two problems I'm going to address. The first problem is that I'm going to obviously be accessing the internet with this application, otherwise it wouldn't be much of an example of how to use APIs, right? So what I gotta do is I have to jump into my Android manifest and tell Android that I want internet permission. So I'm going to jump up here to Android manifest.xml, and underneath the manifest root element, I'm going to go ahead and say uses permission. And for the permission, I'm going to do android.permission, or I guess I could just type in internet. Actually, that is, I think that's a bug here. It should actually be auto-completing to lowercase Android and permission and uppercase internet. Otherwise, it's not going to match the permission correctly. So make sure you got that uses permission. Otherwise, your calls are going to fail. Now, there's a second problem with how this is set up. And that is, I'm actually going to show you guys the wrong way to work with Retrofit for the first examples. Now, unfortunately, the wrong way to work with Retrofit is going to cause an error in Android because it's, well, the wrong way. So what I'm going to do is I'm going to do something a little sneaky up here that I recommend nobody ever does except if they're doing a video tutorial on how to basically use Retrofit. I'm going to come up here and say strict mode dot set thread policy equals new strict mode dot thread policy dot builder dot permit all dot build. Basically, the long and short of it is, by default, if you try to make an API, a web request on the main thread, you will get an exception. Your application will crash. I wanted to show you guys how to work with Retrofit really quickly, if you were in your own thread, if you're in your own background thread, you could work with Retrofit how I'm about to show it to you. But we're not going to worry about putting together any sort of async loaders or async tasks or anything like that. So we're going to be doing everything mostly on our main thread until I show you guys how to work with Retrofit asynchronously. All right, so now that I've disabled the check on Android, which you should never do, what I'm going to do now is, I guess, let's go ahead and put together our first API call. So the first API call I want to put together is going to be the gist one. And the gist one, as you can see right here, is the simple URL, and it returns an array of objects. Now, you saw before that Retrofit said it was strongly typed. The way it does that is it performs some serialization behind the scenes for you, and it has a lot of good defaults built into it, and that's what we're going to take advantage of. So what I need is I need a strongly typed representation of one of these objects. So I want to pull in a couple fields, I guess, just to show you guys how things are working. I want to pull in the files field, and I want to pull in the ID field. So what I'm going to do is I'm going to create a class that'll represent this gist. So I'm going to say public class gist, and I'm going to say public string ID. Now look at the casing here. The casing is significant because the GSON serializer, which Retrofit will use by default, is very picky about its the way the properties, the fields get lined up. Now this wouldn't have been a problem if this were private, but it's public and it has a lowercase ID. Now that's required because of how GSON is going to do the serialization and name matching. You can change the GSON naming policy, which we will do in the later video when we put together the app, but this I'm going to keep as simple as possible. Next up, I want some files. So how would we model this in Java in a strongly typed way? Notice how files is a object, but it's closer in concept to what I would think of as a hash map or a dictionary if you're a .NET person. So what I want to do here is I want to create a hash map of string because that looks like it's the key, and then I'm going to need another object, another class to represent these objects inside of the files array, or files object anyway. So to do that, before I write, I guess I can write this out first, even if the class doesn't exist yet. I can say hash map of string and file, or how about gist file to be a little bit more clear on what we're doing here. And then I'll call this files. Now again, the files needs to match up with this property, this files property. If you wanted to change the name, you could, but you would need to use the serialized name annotation to change the name to what you want, but we're not going to use that here. Now I actually have to create the gist file class. So I'm going to say public class. It doesn't matter if it's public. Actually, it will matter if it's public or private. Let's mark both these as private. Derp. Private class gist file. And for the gist file, what I'm going to do is I'm going to need a couple properties out of that. I'm going to grab, how about the type and the file name? So I'm going to say public string type and public string file name. Okay, so the next thing I'm going to do here, before we move on into how to use Retrofit, this gist class, I'm going to be adding to an array adapter for my list view, because that's the simplest adapter to use. As a result, I need to implement its toString method. So to do that, I'm going to say public, or override public void toString, and I'm going to say string output equals ID plus colon, and I'm basically just going to say for map.entry string gist file in files, and I'm going to say output, files.entry set, and I'm going to say output is going to be plus equals file dot, and I guess for this we'll go ahead and do get key, I guess, and then equals file.getValue.type. So we're not using the file name, but whatever, doesn't matter. You can pull in as many fields or as few fields as you want to accomplish what you want. So in this case, as you see, our strongly typed representation is different than what's actually being returned by JSON, but it's fine. It's not going to throw an error. Also, toString returns a string, because I'm an idiot. All right, let's return our output. So anyway, this toString method just exists for debugging purposes, so we can add it to our list adapter. So I'll go ahead and close that out. You guys take a look at that for a second if you want to pause. Otherwise, I'm going to make it hidden so it doesn't clog everything up. So now let's say now that I have my strongly typed representation here, how would I go about creating a actual endpoint? So to do that, what you need to do is on your interface, you need to create a method. And the method's signature is incredibly important. So for the method signature, what I'm going to do is I'm going to say list of gist, and I'm going to hit Alt-Enter to import system or import list.gist, and I'm going to say get public gists, and I'm not going to provide any parameters. And the most important thing that you've got to do in order for Retrofit to even recognize this as a method that it's going to support is you need to give it an annotation. And the annotation you give it is going to depend on what verb you are using on the API. If you're not familiar with the concept of an HTTP verb, an HTTP verb is a piece of text that describes the intent of the client. So for example, the get verb is typically what happens whenever a browser, in this case the HTTP client, hits a web server. As you can see, this is a get request. I can tell that by hitting F12, jumping over into my network tab, and then hitting refresh, and noticing that this item has the get method right here. Method is another term for verb. So there's other verbs you can use, like delete or put or post. We're only going to be working with get in this video. However, we absolutely will be working with other verbs in the upcoming videos. So basically, you start off by annotating it with what verb you want to use, in this case, get. Now you want to make sure that you import this annotation. So an easy way to do that would be to type in @get, waiting for the autocomplete to come up, then hitting enter. And that'll bring the import statement at the top. Make sure you get that import statement, otherwise your code won't compile. Now, the get requires a parameter, and that parameter is a string, and that string is simply where the endpoint is. So it's going to be gist or gists/public, because as you see, that corresponds to this right here, gists public. So as far as where the HTTP API github.com comes from, that comes from the REST adapter builder. And basically, all of our invocations on our service layer are going to be prefixed with that endpoint. Anyway, now that we have our public gists, let's go ahead and use it. That's literally all. I know I talked a lot, but that's literally all the code we need in order to tell Retrofit about an API endpoint with strongly typed data. And I think that's actually pretty cool, because that's a whole not lot of work to do that. So let's go ahead and get going with this. What I need to do here is I do need to go ahead and I'm going to create my adapter, I guess. I'm going to create an array adapter of object, and I'm just going to call it adapter. Or actually, if we call this adapter, let's call this array adapter, or list adapter, equals new array adapter. And for the array adapter, what I'm going to do is I'm going to provide this for the context. For the layout res, it's going to be android.r.layout.simple_list_item1. Then for the then we need to get our list view. So I'm going to say list view equals cast to list view find view by id r.id list view. It's a lot of list views, isn't it? But anyway, we now have our list view. So now I'm going to say list view.setAdapter list adapter. So now we have our kind of boilerplate out of the way for accessing our list view. So now what I can do is I can go ahead and say adapter or list adapter dot add all, and now watch how easy it is to use Retrofit. Service dot get public gists. And that's it. So you see this method coming off of an interface with these annotations is going to do all the work of deserialization for us, and serialization if you sent data in. It's going to do all the work of sending out the HTTP request, handling errors, and all that fun stuff. So now if I were to go ahead and hit play, or run, or whatever you want to call it, give it a moment to Java. Again, I don't recommend using Retrofit like this quite yet. We'll talk about how to use its asynchronous API in a moment. This is all in synchronous execution. And we get an exception. Of course we do. What did I do wrong? Derp. I meant the get to start with a // I don't know how. I don't know how I've written so many of those annotations, and yet the first time that I ever got it wrong was in a video. Okay, so come over here, and we see the result of that API call. Now, it doesn't look very exciting, but you can actually see it going on here. You can see our toString method being invoked on all this data. If I actually come over here and compare it with what we get here, you'll notice it should line up pretty closely, unless somebody set in the gist too quickly. So if we have an ID, or let's say gist_file1.js with an ID of 31A7. So you see this data is the same. And yeah, so that was it. That really was not a lot of work, and especially if any of you guys are familiar with using anything else, any other sort of way to handle HTTP calls, you might not be really used to how pretty straightforward that is. So let's go ahead and just do a couple other examples. I just want to do another example here. I want to do a user search because that's a little bit more interesting here. So what I'm going to do is I'm going to create a, well, I'm first going to show you what the API call is going to look like. So over here, what I'm going to do is I'm going to say search users, and then as a query string, I'll pass in Nelson LAQUE. So you get my account right here, and you'll see what it returns. So you'll notice there's an envelope. An envelope is a term to describe a way to present additional metadata about a request that isn't necessarily the body of the request, that describes how many things that were returned and if the results were incomplete. And then you see the results here, this items array. And then inside of this items array, you notice that you have all my public account information. Or not all of it, but enough of it to display a search. And you'll also notice that there are links that you can follow to get more information. Like, for example, if you wanted to get additional information, you could copy that URL and go straight to that and get even more information about my profile. I really do like the GitHub API. It's very nice. But anyway, so how would we implement that? Well, the first thing I need to do is I'm going to create my inner user class. And this user class is going to be called a user summary, because this class only has not all of my account information, just some of it. So I'll call this a user summary. And I'm going to go ahead and give him a public string login and a public string ID. And then I'm going to be lazy and I'm going to generate his toString very easily by hitting Alt Insert, toString, hitting enter, and then hitting enter. And that'll just generate this, this fancy little thing right there. Okay, so that's my user summary, but I need to also model the envelope, because the way the serialization works is I can't say I just want the things out of items. I have to actually model the class that the whole object represents. That includes the class that includes the total count and incomplete results and items array. So to do that, what I'm going to do is I'm going to create another class called users search result, which will have a public integer total underscore count, a public boolean incomplete result, boolean incomplete results, and then a public list of user summary called items. And then for the actual call, I'm going to make it a little interesting, because you notice how there's this query string right here, this query string parameter. So this is an example of how we can actually use parameters in our service calls. So the first thing I need to do is the return. The return is going to be a user search result, and I'm going to call this search users, but I need to provide a query string. So I'm going to pass in a annotated parameter of query with the value of Q, and I'm going to call it, now what I call it here doesn't matter as much. We'll just call this query. And then of course I need to annotate it with my verb. So then I'm going to say search users. And that's it. Now what I'm going to do is I'm going to completely replace this gist example for now. So instead of right here, service.getPublicGists, I'm going to change this to service.searchUsers, and I'm going to pass in the beginnings of my username. So now let's hit play. And you see there was one item returned. And you'll notice that, unfortunately, I totally failed here because I passed in the item of the search result itself and not the users. So I want to say add all, but then I want to do dot items. So that was actually, I'm going to leave that in the video because honestly, I've done that myself where I create this envelope and then I treat the envelope as if it were the individual items, and then I'm wondering why my objects don't look like they should. But now they do look like they should. As you can see, that one item is returned and our toString method was appropriately invoked. Now there's one last thing I want to do here, and that is, it's basically two things. I want to show you guys, A, how to properly use the asynchronous API for Retrofit, just a basic summary of how to show you guys how to do that, and B, how to use, how to change the URL itself with parameters, because that's a very common thing to do in REST. Because as you see right here, look, if I wanted to get more details about my user, I would access /users/my username. And so to do that, I want to create an endpoint, an API, on my interface that will allow me to supply that bit of the URL with a parameter, a string parameter. So let's come up here to our GitHub service, and before we write out that method, I do need to write out the object that will contain the data, the strongly typed representation. So I'm going to call this user, not action bar activity. I'm going to call this user details. And I'm going to ask for some information that isn't from in user summary. So I'm going to ask for ID and location, which are both fields that are available in that JSON endpoint. Then I'm going to hit Alt Insert, toString, and Inner, and so that I have this nice little toString representation that'll show up nicely in my list view. Now for the actual call, it's simply going to look like this. User details, and we'll call this, how about get user, and he will have a path of username called string username. And he will be get /users / and then in curly's username. So what will happen now is this parameter is going to replace that bit of the URL. So now what I'm going to do is all the way here at the bottom, I'm going to go ahead and I'm going to say list view dot set on item click listener equals new on item click listener. And then I'm going to say user summary equals cast to user summary list adapter. And now by doing that, of course, the local variable is marked as final because we're now hoisting it into a closure. Then list adapter dot get item and position. Now what I'm going to do is I want to show a toast with that information. And if I were to use it at the moment, if I were to say service dot, and again, service just became final, service dot get user, this summary dot login, what this would do is this would execute synchronously on the main thread, just like what we did before. So how do we avoid that? Well, we introduce the callback. So let's flip this around. In fact, I'm going to go ahead and show you guys the synchronous and the asynchronous call to the same thing to show you guys kind of the difference, to highlight the differences between the two. So for the asynchronous call, and if you guys aren't maybe familiar with the term, what I'm basically saying is I want this network call to happen on a separate thread so that while it's going out and accessing a different server and getting a result back, it's not hanging up the main UI thread and making the application stutter. And this is what you should basically be always doing unless you're already on a different thread to begin with. So what I'm going to do is I'm going to rewrite this get user. I'm going to say void get user async. Oh, come on. Async path username string username. Now notice how I'm returning void, but I'm going to have the last parameter be a callback of user details, passing that as the generic type parameter. And I'll call this callback. And then I'll go ahead and annotate it with get, just like what we did before. So that's the difference. This is an asynchronous call. This is a synchronous call. The only difference is the return type is going to be void, and the final parameter is going to be a callback. And not surprisingly, if you've done much Java, you can probably see where I'm going with this. So the callback is going to be invoked when the asynchronous call is finished. So now what I can do is I can scroll back down here, and instead of saying service.getUserSummaryLogin, I can say service.getUserAsync summary.login, and then new callback. Now, again, what I did there, for people who haven't been following along with the series, I want to point out that I typed in capital CAL, selected this, and made sure that the autocomplete that I selected has this ellipsis right here between the curlies. Hitting enter will create me that really nice anonymous inner class, and it'll stub out the required methods. And you'll notice that two methods appear now, success and failure. So obviously, the success method is invoked when the API returns a success status code, and the failure is invoked when the API returns a non-success status code, such as 401 bad request or 404 not found, or ISE 500, or it couldn't even connect to the internet, or something else, it timed out. So failure is where you can handle your errors like that. Otherwise, exceptions are thrown in the same context if you're running the synchronous call. But with success, look at that. I think that's really cool. I think right there is really the power with Retrofit, because you'll notice that the success, because I typed it to user details, it accepts a user details object, and that's going to be filled and populated with the data that was successfully returned by the API. So now what I'm going to do is I'm going to say toast.makeToast. For the context, I'm going to pass in main activity.this. I have to do that because I'm actually nested in two anonymous inner types. And for the character sequence, I'm going to pass in user details.location, and for duration, I'm going to pass in toast short, and then I'm going to do .show. And now if I hit enter, you'll notice that I'll be making an asynchronous call on a background thread and getting my awesome strongly typed API to work for me. So come over here. Now if I click on this user, my location appears. Now, of course, this is very, 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 very quick. If GitHub was slowed down for some reason, then what would happen is the main UI thread would still be running, and I could still interact with the application. And then finally, when that request completed, then the toast would appear. Because again, I'm using the asynchronous API here, and it's basically what I recommend anybody using Retrofit will use. Now, there is a little bit of complexity and redundancy when dealing with the success versus failure. I'm going to resolve that in the application that we're writing by writing a callback shim that will abstract away some of that details and make it work a little bit more appropriately with the way we've written the application so far. But this is bare bones Retrofit, and as you can see, hopefully its power and ease of use is fairly apparent at this point. So there's not a whole lot else to say that won't be said in upcoming videos, so I won't bother, except check out the documentation if you ever get stuck. You can send headers, you can send post bodies, you can send different verbs, you can set up interceptors and all that fun stuff. It's a very powerful API, and I really enjoy working with it. Anyway, I guess it's time to, now that we've got the preliminaries out of the way and you guys kind of see where I'm going with this, let's start actually implementing this in the app itself so we can finally get some production use out of the API. So we'll see you guys in the next video.